Alrighty, friends, let's do 10-3, probability and odds, which I think a lot of people think probability and odds are the same thing because we kind of use them interchangeably, but mathematically they're different. So let's figure it out. So probability, like you guys kind of get it. Like if there's 4 equal spaces on a spinner, your probability of landing in one of them is 1/4. And the reason is you're doing a fraction or a comparison or a ratio, and we say like it's the number of what we call desired outcomes. And what that means, like, what are you trying to get? Are you trying to get it spin a 4? Are you trying to spin green? You're like, what are you trying to get? So the number of desired outcomes out of the total possible outcomes. So, 1 out of 4 is the winning number or whatever it is you're trying to do. So this is the total possible outcomes. That is a fraction. And you can never have more than the total. So the fraction, like the biggest it can ever be is that the top and bottom are equal. And if you had like 5/5 or any number over itself, keep in mind that that'll max out at 1. So probabilities all end up between 1 and 0, because 0 would mean that what you're trying to make happen never can happen. There's 0 ways it can happen. So say you're rolling dice and you want to get a 7. Well, it's not going to happen because your die only goes up to 6. So then that would be 0 desired outcomes out of the 6 possible, and 0/6 would be 0. So all of our probability answers are going to be between 0 and 1. And when something must happen, like it's absolutely going to happen, we say the probability is 1, and we call it a certain event, like it's certainly going to happen. But if it cannot happen, then the probability is 0, and we call it an impossible event. So if it's impossible, truly the probability is 0, and if it's absolutely going to happen, then it's going to be 1. So if you're rolling dice and you're saying, what's the probability that I get something less than 1? Well, less than 7. Well, your probability is 1 because like you have to get something less than 7. So you roll a 6-sided die, find the probability of rolling a 5. And so it might be written like this, probability of getting a 5. So up here, you're going to be like, okay, the number of 5s is the desired outcome over the total number of options. Well, you're rolling a 6-sided die. So only one of them is a 5, and there's 6 possible outcomes. Now, you can also write it as a decimal, which would look like 0.16 repeating, or you can bump that over 2 spots and call that 16.6 repeating percent. It doesn't really matter how you write it, fraction, decimal, percent, so kind of whatever is easiest for you. Okay, how about an even number? Well, when you roll one die, you get a 1, a 2, a 3, a 4, or a 5. Of those, only 2 and 4 are even numbers. So if I have the probability of rolling an even number, I put the number of possible even numbers, which is 2, because I could get a 2 or a 4, over all the possibilities. Oh, you're rolling dice. Sorry. So there's also a 6. Wow. Okay. So then that's going to be 2, 4, or 6. And so I have 3 options out of the 6 options, which reduces to a half. I could write it as 0.5 or 50%. So any of these would represent the probability of getting an even number when you roll that one die. I don't know why I had that particular brain fart, but who knows. Now you're going to roll 2. Okay, so that's where you should use that chart that we had that showed all the dice. And so you can look at that as we go. So find the probability of rolling a sum of 6, meaning the dice add up to 6. So if you look on that table that we have, and I don't know, I don't have one on here, which would be super, what's that called? Convenient. Wow, big words. Now, there's 36 options on that little chart. If you look at all the ways you can find a sum of 6, and by the way, you're going to find them in like little diagonal spots, and there's going to be 6 ways actually there's 5, because I can't count. 5 ways that can happen. Or as a decimal, 0.138 repeating. Or if I move that over to, that would be 13.8 repeating percent. Okay, again, however you want to express that. Doubles. Okay, well, you could get double ones, twos, threes, fours, fives. So in the end, there's 6 ways you could get doubles out of the 36. So once again, that reduces to a sixth, 0.16. Boom, boom. If you want to move that over, you would have 16.6 repeating, or 16.7-ish percent. So these are all the same answers, just written in different formats. Okay. So there's a talent contest and 7 musicians are scheduled to perform. The order in which they perform is randomly selected. What is the probability that the musicians perform in alphabetical order by last name? Okay, so the probability that they go in alpha order, keeping in mind there's only one way that they would be in alphabetical order out of all the ways. Now, counting up all the ways is where all the stuff we did in 10, 1, and 2 comes in. Because if you have 7 musicians and they're going to go like in order, you can do that one or two ways. You can say, well, that's 7 place 7, because I'm putting them all in order. Or you would think of it as 1 over 7 factorial maybe, because you're thinking, well, I have 7 choices, then 6, 5, 4, 3, 2, 1 in terms of what order they go in. And I'm going to end up with 1 over 50, 40. And honestly, I just leave that as a fraction because it's the easiest way to do it. Okay, you are friends with 4 of the musicians. What is the probability that the first 2 are your friends? Okay, so if you have, think of it as people who are your friends and then people who are not. So what is the probability that the first 2 performers are your friends? Well, how many of them are your friends? 4. And how many of your friends get chosen in this scenario? 2. Okay, what about people that are not your friends? Well, you have a total of 7. So if 4 of them are your friends, then 3 of them are not people you know. And from that, you're choosing... Oh, actually, that's all you got. You got, I'm on the struggle bus here, kids. Sorry. So I have 4 friends. I don't really have 4 friends, but we're pretending. So 4 friends, you're going to choose 2 of them to go first. But now I have used up 2 of the people out of the 7. So now I have 5. And then I'm going to keep going on down from there. So 5, 4, 3, 2, 1. And that's going to be the ways that my 2 friends get picked to go first. But then on the bottom, I still have my 7 factorial or 7 choose 7. You can write it kind of however you want to, whichever way makes the most sense. So the other way to think about that is here, I could have taken 4 friends. I'm placing the first 2 in order. Probably should have used a P back here because it matters what order they're going in. And then 5, 4, 3, 2, 1 is 5 factorial. And on the bottom, I have 7 factorial. So it's really tricky because now you're taking all the counting we learned and putting it into these probabilities. And when you do this all out, believe it or not, it just comes out to be 2/7. So that's going to be a calculator thing to figure that all out and make sure you can land at 2/7. And 2/7 is going to look like, if you do it as a decimal, 0.2857-ish. So if you get that, that's the same thing. Okay, you're playing a card game with a standard deck of cards. So you also have cards on that chart, and we can talk about that because you need to know a little bit about what they're talking about, like hearts and spades and so on. You're going to get dealt 5 cards. What's the probability that you get 5 spades? So spades are one of what we call the suits. And if you look on your chart and you count up the spades, you're going to have 13 of those. But from those 13, you're just choosing 5. And here it wouldn't matter. They're not getting specifically placed. You're just getting a group of them in your hand. And then the total possible 5-card hands would be all 52 cards in the deck, and you're going to choose 5 of them. And we can go through the charts and make sure you feel like you understand what those are showing you. So this top number turns into 1287, and the bottom turns into this giant number. But that's how many 5-card hands you can get. So if you leave it like that, great. If you try to do it as a decimal, it does give you 4.95. And then further down there, you're going to see an E negative 4, because that means times 10 to the negative 4, which is scientific notation. You've probably seen that, because it means that you actually have to move it over 1, 2, 3, 4 to the left. So it'd be 0.000495. So it gets a little confusing, but watch for that. I just meant to highlight that, sorry. Watch for that E to the power, and it means that you're moving that decimal negative, or you can leave it as a fraction. What is the probability that you get 2 5s and then 3 7s? Okay, well, let's look at that. In order to get 5s, there are 4 5s, one of each suit, and you're going to choose 2 of them. And then to get 3 7s, there are 4 7s, and you're going to choose 3 of those, over, again, the 52, choose 5, because that's all the different ways you could get 5 card hands. So when you do your calculator, there's only 24 ways on the top to get the 2 5s and the 4 7s, and then that bottom number stays the same as it was before, because that's still the number of 5 card hands you can get. And you could probably reduce that. Quite honestly, I'm not sure. Let's see, 24 divided by 2, 5, 9, 8, 9, 6, 0. Again, get an E, 9.23 times 10 to the negative 6. That's a fine answer. It also means that you'd be moving this over 1, 2, 3, 4, 5, 6. So another good answer is 1, 2, 3, 4, 5 zeros, 9, 2, 3. So this, and this are all perfectly fine answers. All right, so at the beginning I said we were doing probability and odds. And odds is a little bit different, because instead of comparing the thing you want to have happen to the whole, all the options, you compare it to the other part. So like whatever you want to have happen. So you end up comparing like part to part, not part to whole. So odds in favor of something happen means you count up the number of things that you want to have happen, and then you compare it to the number of things that you don't want to have happen. So you don't necessarily do the total like we did in probability. And you can write it like that with a colon. You can write it as a fraction, so you would have like the things you want over what you don't want. And then odds against is the flip-flop. You go, well, against what I want. So the things you don't want to have happen compared to the number of ways what you want could happen. So let's look at an example. It says the odds in favor of drawing a 10. So you're basically going to, because it's in favor of, you're going to do the number of 10s compared to things that are not 10s. So if you look at that chart that has all the cards, there are 4 10s. And in the 52 card deck, that leaves 48 cards that are not. Now you should reduce it, and since those both divide by 48, you would say the odds are 1 to 12. You could write it as 1 over 12. But what's different is the 12 on the bottom is not showing the total, it's showing the things that were not 10s. So either this is an answer or this. The odds against drawing a club means you would put the things that are not clubs first, compare it to the number of clubs. So if you look at that chart, there's 3 suits that are not clubs, and that totals up to your 39 cards, and then 13 that are. Again, that reduces by 13, and you get 3 to 1. So the odds against drawing a club are 3 to 1, or you could write it as 3 over 1, whatever makes sense. I honestly like to write probability as a fraction and odds as this like ratio with the colon, because it makes more sense. Like the odds are 3 to 1. You're 3 times more likely to get something that's not a club than one that is. And up here, you're 12 times more likely to get something that's not a 10 than to actually get a 10. So let's just do this last thing. The odds of getting a 2 on a spinner are 2 to 5. Okay, so keep that in mind. That means this is the number of 2s, And this is the number of things that are not 2s. What is the probability? Probability is still going to take the number of 2s, which weirdly enough is 2, but it has to be over the total. So if you have a spinner where 2 of the numbers are 2s and 5 of them are not, you're going to have 7 options on that spinner. So it's just kind of showing the difference that, hey, yeah, if you wrote this as a fraction, you'd have 2 to 5, but that's the ones that are 2s compared to the ones that are not. Whereas this is comparing the ones that are 2s to everything on the spinner. So in order to get the total here in odds, you have to add the 2 parts together. So here, last thing, this is comparing part to whole. This is comparing part to the other part. You know, the part that is 2s and the part that is not. So odds and probability are no joke. They're a little bit tricky. You got to use your big brain. And we're going to practice it for a few days together, but that is good enough for an intro. Bye, guys.